Hello everyone, I am Dhiraj Agrawal and here I am going to give presentation on high performance liquid chromatography. But before we start, we should know what is chromatography. For that, I am giving you brief idea about chromatography. Chroma means color and graphy means writing. It is used in many specific fields, used in many subjects and applied in all analytical fields. Chromatography is a method of analysis and separation technique of organic and inorganic compounds. It is used for large and small quantities, so it is used quantitatively and qualitatively and proved to be more effective from the other, means the separation and identification. So here we got idea about chromatography. Now I am going to start high performance liquid chromatography. High performance liquid chromatography, that is also called as HPLC. As its name suggests, high performance means it will give proper separation, then it will give identification, then it will give also gives quantification of our mixture compound. If sometime it is also known as high pressure liquid chromatography, because in this technique high pressure is used, that pressure is from 1000 to 4000 psi for proper separation and rapid separation for the mixture of compound. So this is an analytical technique used to separate, identify and quantify the mixture of compound. Then it gives high performance due to smaller particle size of the stationary phase. So particle size in HPLC it will be 3.5 to 10 micrometer. This is the size of stationary phase. So due to lower part of particle size, surface area will be increased and ultimately HETP, high equality theoretical plate, high equality theoretical plate will be increased. It will give better separation of mixture of the compound. Now so here particle size of stationary phase is smaller due to the particle size packing up or stationary phase will be tight. In due to the tight packing, flow rate of the mobile phase will be reduced. So increase the flow rate and increase the efficiency, increase separation of the compound due to applied high pressure, and that pressure is 1000 to 4000 psi. In case of HPLC, that is high performance liquid chromatography. Due to this process, sometime it is also known as high pressure liquid chromatography. Now coming to the theory of HPLC column. So theory of HPLC column was described Van Dimter equation. This is Van Dimter equation. HETP is equals to A plus B by mu plus C mu. So HETP is high equivalent theoretical plate. A is eddy diffusion, B is longitudinal diffusion, C is mass transfer rate, then mu is flow rate of mobile phase. As discussed about this Van Dimter equation for HPLC, so here value of longitudinal diffusion is equivalent to negligible earth 0. So Van Dimter equation for HPLC will be HETP is equals to 1 A plus C mu, because the value of B by mu is negligible. We are removing B by mu from the Van Dimter equation. This is the equation for HPLC. Now moving to the principle of HPLC system. So coming to the mobile phase used in HPLC, there are various solvent which can be used in chromatography technique, and this for solvent give here. But in HPLC there are some solvent which are commonly used. Generally they are invoicing organic compound by using HPLC, and all organic compound are soluble in polar solvent. So generally we are using methanol, acetonitride and water as a mobile phase in our column chromatography, because generally we are using reverse phase column chromatography. So commonly used solvent are acetonitride, water, methanol, and in this solvent are adding we are adding acidifier, basifier, buffer solution for better separation, because this acidifier, basifier and buffer solution will neutralize, ionize, analyze or analyze compound present in our column, so separation will be better. If our compound will be ionized, so efficiency will stationary phase will be lost. Their proper separation will not be there. Means every analytes come with the mobile phase. Immediately come with the mobile phase. So there will be no difference RF value and separation will not be proper. Now coming to the stationary phase used in HPLC. So particle size of stationary phase used in HPLC is 3.5 to 10 micrometer because fine particle are used for better separation. And two types of stationary phase is used in HPLC. First one is normal phase. In normal phase we are using silica gel, and stationary phase in reverse phase we are using ODS silica gel. What is ODS? ODS means octadecyl silent silica gel. ODS is the cyclic hydrocarbon which contain C18 means 18 carbon atoms. Now coming to the column used in HPLC. It is a heart of HPLC system. So two types of column used in HPLC. First one is normal phase column which contains silica gel, normal silica gel. Second one is reverse phase column which contain octadecyl silent silica gel or C8 hydrocarbon which is known as C8 column. Now coming to the instrumentation of HPLC. The major part of this instrumentation is solvent reservoir, degassed or solvent mixture value, free column, analyte column, detector and recorder. Now coming to the instrumentation part of HPLC. So I will show the block diagram of for instrumentation of HPLC. So this is a block diagram for HPLC. Coming to the difference part of HPLC. So first one is solvent behavior. Solvent reservoir is used to store mobile phase in HPLC, and in HPLC two types of solvent reservoir is there. First one is binary system and second one is quaternary system. In binary system, two bottles will be there. Two bottles are two reservoir of solvent will be there. In quaternary system, four bottles or four solvent reservoir will be there. So in HPLC we are using specific type of solvent, and that solvent would be filtered, that and that is known as HPLC bent solvent. So in HPLC solvent any type of particle are absent. Now coming to the second part which is degassed. Degassed is used to remove the gases are dissolved in our mobile phase or in our solvent. So degassed done by using vacuum pump means vacuum pump remove all the air or any types of gases present in our solvent, so it will give better separation. If these gases will be entered in our mobile phase and it will go to the column, so proper functioning of column will not be there, means proper separation will not ended. So this degas using remove the gases in the solvent. Now coming to the next part which is solvent mixing valve. So this valve will be used to mix the solvent. So if we are using binary system, then two solvent will be mixed together. If you are using in quaternary system, then four solvent will be mixed together. So all this solvent will run through the pipe. This is a pipe and diameter of this pipe is 1 by 8 inch. All these pipe using in HPLC for flowing of mobile phase in made up of PTPF, that is polytetra fluoroethylene, and it is also known as diphenolone. Now coming to the next part of HPLC pump. So there are two types of HPLC pump use. First one is the constant pressure pump and second one is the constant flow rate pump. So constant pressure pumps means pressure of uh, The pump will be constant for so flow rate may varies and this will not give proper separation. And in second part, constant flow rate pump is there, so here flow rate it will be constant and pressure may be changed, means according to our column resistance pressure will be changed, and due to that pressure change our flow rate will not affected, means column resistance will be high, then pressure will be high. To maintain flow rate, it column resistance will be flow rate lower, then pressure will be also lower to maintain the constant flow rate. Generally, we are using 1 ml per minute flow rate in HPLC system. Now, coming to the next part of pre-column or God column. So, as its name suggests, a pre-column, it means it will be used before the analytical column. What is pre-column? So, pre-column used to protect our analytical column, means our stationary phase will be same in pre-column and our solvent first to go to pre-column, and after that our solvent we go to the analytical column. So any type of contamination presenting our solvent will be removed by the our pre-column, and after conditioning it will go the analytical column. So ultimately it will protect our analytical column. Size of pre-column is also smaller as compared to analytical column size, is approximate 2 to 10 centimeter, and size of analytical column is 10 to 25 centimeter. Now coming to the next part, which is injector. So there are three types of injector used in HPLC. First one is the spectrum injector, second one is the stop flow spectrum less injector, and third one is the micro volume sampler. This is a modern simple sampler injector are used in HPLC. By using this injector, accuracy will be occurred. Highest accuracy will be occurred, and also an and also sampling auto sampling technique is applied by using this injection. Now coming to the next part, which is detector used in HPLC. So various detector are used in HPLC, just like refractive index detector, which is bulk or properties detector. Second one is the conductivity detector, which is also bulk property detector. Next one is the UV visible detector, which is concentration detector. Next one is the fluorescent detector, which is also known as dependent on concentration of solute. And next one is approximate and next one is amperometric detector. This one uh, example of electrochemical detector. So this is the overall view about the high performance liquid chromatography instrumentation. Now types of HPLC. We are already discussed about types of HPLC. Then next one is application of HPLC. The main purpose of HPLC technique is identify, quantify and verify particular analyte compound. Both quantitative and qualitative analysis can be done. Thank you everyone for giving your valuable time for this presentation. Thank you.